Hello, our most valued student. My name is Confident. Welcome to our grade 11 revision session, and this is focusing on question 2. I did a previous lesson. I will encourage you to watch the previous lesson called part 1 of algebra. This is part 2 of algebra. So I'm looking at question 1 and question 2, and this is a previous paper that I took and I thought of revising it with you. So as I said, we are only focusing on question number 2. In this case, as I said, I did previously question 1, and I will encourage you to grab hold of the previous lesson just to give you a sneak peek of what we did. We did in the previous lesson question 1 where we were solving for x, question 1.1, and 1.2. It was a simultaneous equation and we were solving that, and it was out of 20 marks. So I've already done this section, but now I chose to focus on question number 2, and it's out of 11 marks. And how will you approach such a question in your exam? So the first question, 2.1, it says simplify the following fully, and they've given you that 3 to the power x plus 1 minus 3 to the power x minus 1 over 2 times 3 to the power of x. This is 3 marks. So if I can write it here to say you have got 3 to the power, in this case that's 2.1. So we have 3 to the power of x plus 1 and minus 3 to the power of x minus 1 all over 2 dot, and then we have 3 to the power of x. So this is what we have. Now it's not a complicated problem. This is mainly testing your previous knowledge work, which is grade 10. But what are they trying to test here? They are looking at your knowledge of the laws of exponents, and there is one law that is common, the first law of exponents, law 1, which says 3 to the exponent x, I mean not 3 in this case, it's a. For example, a to the exponent m times a or dot a to the exponent n is equal to a to the exponent of m plus n. So what is this about this law? When the bases are the same and each base, there's an exponent, you write the base and you add the exponents. Now this same law, you can write it, so it was going this direction, I can write it in this direction, whereby I can say a to the power of m plus n, this is equal to, then I will split it into a to the power of m, because the exponents are adding, it will be plus a to the power of n. You can see that I have got a single exponent, and this then produces 2 exponents. Actually, it's not plus, it's times. Sorry about that. It's a to the exponent n times. Remember, I'm going in this direction. So it means if the exponents are adding, you multiply in between. If the exponents are dividing, then it's subtraction. So this is the law here, which I want to use in this particular case. Meaning, if I'm given, for example, 3 to the exponent, for example, 3 to the exponent of x plus 1, just like in these two, it will be equal to, where there is a, now I have my 3 to the exponent, where there is m will be my x, times 3 to the exponent, where there is n, I have my 1. So you see how I'm trying to look at it from that angle. So what I will have here will be 3 to the exponent x times 3 to the exponent 1 minus again 3 to the exponent x times 3 to the exponent negative 1 over 2 times, or 2 dot 3 to the power of x. Why was I doing that? I was doing that so that you can see 3 to the exponent x, 3 to the exponent x, it becomes common. Then I can factorize it out. So I will have then 3 to the exponent x, factorize it. In the first one, what will remain after factorizing will be that part, which is 3 to the exponent 1 minus, Again, on the second one, that will remain inside the bracket, 3 to the exponent negative 1 all over 2 dot 3 to the exponent x. Then this will be equal to, at this stage you can see that now I can cancel out 3 exponent x. Then the question here was not specific. They didn't say, they just said simplify fully. They didn't say without using a calculator. In some cases they say don't use a calculator. Since they didn't specify, what you can do, you can then come and say 3 to the power 1 minus 3 to the power negative 1 over 2. You can literally write the final answer straight away from here, which will be 3 to the power of 1, which is 3, minus 3 to the power of negative 1 all over 2. Then it can give you the answer as 4 over 3 in that case. But now, should they have said simplify without using a calculator, what you could have done, you could have said now from here 3 1 minus 3 negative 1 over 2. This is same as 3 minus 3 to the power negative 1 is 1 over 3 over 2. Then this is over 1. Then you solve the top part, which is when you solve the common denominator, there is 3 at the top. So it's 1 into 3 is 3. 3 times 3, it's 9. Minus 3 into 3, 1. 1 times 1 is 1. Remember, this is divided by 2. And then it's fractions. They just want to check if you know your fractions. So 9 minus 1, it's 8 over 3. Divided, you change it times. 2 over 1 will become 1 over 2. So that will become 2 into 8 is 4, which is 4 over 3. So this is a scenario where they will say do not use a calculator here. So it's like a no calculator, what they'll be doing here. No calculator. Are you with me, guys? So that's what they'll be wanting you to show that. But anyway, the answer there is 4 over 3. Now you can test this particular question. Let me just bring something to you here. Say testing. It's possible to test this particular question. What you do is choose any value of x. For example, you can say let x be equal to 5. Just any value of x. Take a calculator, and wherever there is an x, you must put 5. It must simplify to our final answer. Remember, our final answer was 4 over 3. So we must get here the simplified version of 4 over 3. Whatever value of x we choose, it will still go to 4 over 3. So you can do that even before you use the calculator. You could have actually done that. So let's do that. We said let x be equal to 5 in this case, and we will have in 3 to the exponent 5 plus 1 minus 3 to the exponent 5 minus 1 over 2 times, dot means times 3 to the exponent 5. You see that? And you see, when I simplify it, it gives me 4 over 3. It doesn't matter any value of x you choose. I can choose 50 there, just put a 0 there. I can choose also to have 50 there, and then I can choose down there to have also 50. To be too big, but still it will give me 4 over 3. So that is how you can test yourself that you are doing the right thing by doing that. So that is the first part. Now let us move on to the other question. The other question, 2 so this was 3 marks. Now let's look at the next one, 2.2, 4 marks. It says we're supposed to solve for x. We're given square root of x minus 2 to the power negative 3 is equal to 64. If I can write it also here, what we're given is square root of it's x minus 2 in brackets to the power negative 3. I hope I'm writing right. Square root of x minus 2 to the power negative 3 is equal to 64. So now look at this. This is what I'm having here. From what I am having here, what I need, remember I'm solving for x in this case, so I need to understand a few things just to put a little bit of also background. When you see square root, that sign means I can change it into bracket and I put a power half. That's what basically it means. So that is the first part. Now if there is an equation whereby inside here there is x is equal to 4, to get rid of that equation there are two ways. I can just simple square there and square both sides. That's how I get rid of that x. Or as I said, that square root means x to the power 1 over 2 is equal to 4. Then I can multiply by 2 over 1. What I do on the left, I do on the right. 4 to the power 1, because there is a default one there, times 2 over 1. So whatever case, it will still become x is equal to 4 squared. Like here also x is equal to 4 squared. So that is that you need to know. So what I'm going to do here, as I said, there are two ways. I can approach it by squaring already both sides, square both sides to get rid of the square root and square both sides. Now they didn't say without using a calculator, that makes it easier. So I will rely on the calculator in this part. X minus 2 to the power negative 3 is equal to 64 squared. That is the part. Now I need to get rid of that negative 3. Now there are different ways you can approach this. I can actually multiply there by negative. Remember, this is negative 3 over 1. I can multiply by negative 1 over 3. The inverse of that. The negative will get rid of the negative. The 3 will cancel the 3 so that I've got x minus 2. But what I do on the left, remember, put a bracket again. You say times I can put a 1 there, but I can say, because this is like 1, but it's negative 1 over 3, that is important there. So it will be 64 squared to the power negative 1 over 3. Now what happens is that bracket means the exponents are multiplying. So I will have x is equal to 2. The 2 will come this side to become a plus 64 squared now to the power negative 1 over 3. I'm using this because the calculator, as I said, I'm relying here on the calculator, and the calculator will give me the answer in this case. Hence, I'm not going further with algebra. Now, look at this. The answer will be 2 plus, and then I have 64 squared. Then I close that, and then to the power negative fraction 1 over 3. See that? The calculator can deal with the rest. It's 33 over 16. So that is 33 over 16. That's the value of x that I'm getting. Now I need to prove it, test it. Where there is x here, I'm going to put what? 33 over 16. Then let's see what it will give me. It must give me 64. Remember, the answer says that when you put here 33 over 16, you must get what? 64. So let's do that. And I have square root of 33 fraction over 16, and then minus 2, it was actually supposed to be in brackets, to the power negative 3. So let me go and close because I didn't open that bracket, so I need to open it here. So if I do that, I must get 64, which is what I'm getting. You can see that this is 64. So that is fine. But now, what if you were saying, okay, this is fine, but suppose they say don't use a calculator. Now, are you stranded? The answer is no. Now, if I can write this again, it was square root of x without using the calculator now. X minus 2 to the power negative 3 is equal to 64. So now, what do? First things first, using the laws of exponents. Remember, I told you the square root sign means that and that to the power half. That is the part of that square root. So it will be x minus 2. All right. Then you have got the inner bracket of negative 3. So it's more like this one is the bigger square bracket like that to be just proper, is equal to 64. Now, these two, let me use a different marker now to say, look at these two exponents. They are multiplying each other. So you are multiplying 3 times half. So what you're going to be having is x minus 2. Now, if you say 3 over 1 times half. This is a negative, so it's 3 is same as 3 over 1, so it's negative 3 times 1, which is negative 3 over 2. So that's what you'll be having in this other multiplication there. So you'll have negative 3 over 2, remember these are exponents, is equal to 64. Now it is your duty to know what is 64. Now 64 I think is 2 to the power of 6. You need to know at this stage that 64 can be written in terms of 2. So what some calculators do is they can actually able to tell you, I think if you say 64, you say equal to, you press shift and there is that particular arrow on my side, it says fact. If you press it, it will give you the value of 64 in terms of 2 to the power of, if you're using other calculators. So now you see that it's 2 to the power of 6. When I've done that, how do I get rid? Remember, I'm not using a calculator now, I'm using the laws. How do I get rid of that exponent? I multiply by the inverse. It is negative 3 over 2. I multiply by negative 2 over 3. Alright, it's just to use with a different marker. So it's negative. Why the negative? Because it must neutralize that other negative. So it's 2 over 3. If it was positive, no problem, but you must leave your answer, remember, being positive. What I do on the left times negative 2 over 3. Remember, it's 6 over 1 in that case. So when I've done that, then this will cancel out such that I've got now x minus 2 will be equal to, the 3 cancels the 6 to give me 2. So it will be 2 to the power of 2 times negative 2. That's what I'm having. So x is equal to, take 2 to the other side, it will be a positive 2 plus, now it's 2 to the power negative 4. Now what is 2 to the power negative 4? It will be x is equal to 2 plus, to get rid of that negative you say 1 over, then you say 2 to the power 4. Now remember, 2 to the power 4 is 2 times 2, which is 4, 4 times 2, 8, 8 times 2, 16. So it will be x to the power 2 plus 1 over 16. This is over 1. Now common denominator is 16. 1 into 16, it's 16 times 2 is 32, plus 16 into 16 is 1. 1 times 1 is 1. Then 32 plus 1, it is 33 over 16. You see, I managed to do it just purely without using a calculator, but following the algebraic laws, as well as, of course, you need to know your fractions in that case. Alright, so this is that, guys, and I hope this is also beneficial to you. Now remember to subscribe. Just a key thing before I continue, subscribe to our channel, forward or share this channel with your friends and colleagues so that they can also benefit, and make sure that you turn that notification button on so that you can be notified every time there are new videos. Now this is mathematics, the 24-minute lesson, and I usually call it, it's for the underdogs, meaning for those who feel like they're struggling with their maths, and I'm here to assist you. Now last question, 2.3 says rewrite the following expression as a power of x. See, rewrite the following expression, see that, as a power of x. Okay, I didn't says we are rewriting this following expression, and when we are rewriting it, says we must rewrite as a power of x. A bit confusing because I don't know whether they want me to simplify or what, but if I'm to rewrite this just as a power of x, okay, so I must rewrite this expression. So the question is actually clear. I've got an expression here. That particular expression, I must change the square roots things into powers. So what I have, if I can write it, I have here x. That's how they brought it. They brought x, and then the first big square root, and then there is x inside it, and then there is another square root which has x inside, and then there is another square root with x inside. So if I can have it, it's more like you've got this. Alright, then everything is if I can continue now, this is all over, just to use a different pen, it's 8th root of x 7. So you've got 8, then you've got this x 7. Now first things first, if I'm given the first one, see that one, I think I can start from this one. It has got only one root, which is in yellow. So that one, remember, square root means that to the power half. Are you getting that? So the first x here in yellow has got this x to the power of half. And then what about the one in blue? The x in blue here has got two of them of the square roots. So it has got kind of that and that. Are you seeing that? Which means it's that bracket with okay, which is to the power half. So there is x inside, and another bracket to the power half. So when you do that, remember these two are multiplying. It's x to the power 1 over 2 times 1 over 2. It's x to the power 1 over 4. Now the last one, which is that one, is having 3. 1, 2, 3. Then there is x in it. So it means you will have the first one, x, with a half. You'll have the other one with a half. You'll have the other one with a half. So when you multiply 1 over 2 times 1 over 2, it's 1 over 4 times 1 over 2, it will be 1 over 8. So it's x to the power 1 over 8. Are you seeing that? Then lastly, if you are given this one, 8th root of x to the power of 7, now that 8 is similarly like this. It's 1 over 8. Then you've got x to the power 7 inside. But remember, 7 and 8, they are multiplying, which is same as x to the power 7 times 1 over 8, which is equal to x to the power of 7 over 8. So when you simplify this thing now, to say how do you simplify this, it will be x, which is that one, then the first one, which was in dot, the one in yellow, and then dot, you have got then the one in blue, which is x to the power 1 over 4, dot, then the one in green, which is equal to x to the power 1 over 8, and then all over, see, then you've got x to the power of 7 over 8. So they say it here, rewrite the following expression as a power of x. You see, actually this question wants me to simplify, though it's not clear, but they want me to write it as a power, not as powers of x. So if they're saying as a power, it means as a single power of x. So it means I'm a simplify actually here. It was a tricky question the way they asked it, but I cannot leave it like this. So this is power 1. I must use the laws of exponents. Remember, on top, same base, I add, this is 1 plus, then you add there 1 over 2 plus, then you add 1 over 4 plus, then you add 1 over 8. And then if it's dividing, it becomes minus, and then you have 7 over 8. You can simply do that straight away, because at the bottom it becomes minus. Then this then will become x to the power. You can then simplify that with the calculator, which is 1 plus 1 over 2, and then it's plus 1 over 4, and it's plus 1 over 8, and it's minus 7 over 8. Alright, so the answer there becomes 1. So it is x to the power of 1. So the question is, write the following expression as a power of x. So I must write it as x to the power of 1. So this is that expression. I can just test it again. I think I can test this. So if I go to the original, have a calculator and choose any value of x. Let's say my x is 15. So I'll try to enter this into my value of x. So it's a fraction. The x is the 15. Then I've got square root of 15. Then I've got square root of 15. Then I've got square root of 15. That's what it looks like there in that particular. Then over. Then I've got shift that, which is the 8th root of 15 to the power of 7, right, equal to, you see, I'm getting 15. The moment I put 15, I get 15. Which means if I put 20, I'll get 20. Which means if I put x, I will get x. So which means my answer is correct. That number I put in there is becoming the final answer. So here, it means since x is inside here, the answer is that x that is inside in this case. So which means I am correct. Now remember guys, the purpose of this session was to revise with you some algebraic concepts. The aim is not the answer, but the approach to the answer. Now, let me give you something outside the lesson here now. Just a quick motivation. I also struggled a lot with my mathematics. It was a challenge, a big challenge for me when I started my maths in the lower grades. I always struggled with it up to a point whereby I ended up seeking someone to assist me. Lucky for me, I got this other guy who had dropped out of university, and he assisted me in a way. I mean, I don't think he knew what he was creating in me, but what it did for me, I will always appreciate, because I moved from being an underdog in the subject, and then I ended up getting a distinction in maths. I was very horrible at the subject. I used to struggle a lot, to a point whereby I used to get, I'm talking of the last, level 1. I was underperforming when this subject was concerned. From a lower grade, I struggled with it, but I managed to work my way out of it. And that is why I'm so passionate for you guys who are struggling with your maths, because when I'm working towards this, I'm not looking for someone who says, I'm a genius, I already know the answer before I start working on it. I'm looking for someone who says, I'm struggling, I can't even see where to start from, I can't even see where to begin, but that is my candidate. That is the person I want to assist. And I say, you can do it. Just remember, it is possible. You just have to persevere, just need to hang on there, follow up on these videos, and I guarantee you, you will never regret. I've come to the end of my lesson. Thank you.